In today's lesson, we're going to be discussing solving linear inequalities. By the end of today, you should be able to do things like solve and graph simple inequalities as well as compound inequalities. Alright, so let's get to it. Let's see, how do we solve and graph simple inequalities? First of all, you want to know that you solve using the same process as an equation. One slight thing that you want to keep in mind is, though, that you always want to have the variables, your x or your b or whatever it might be, end up on the left-hand side. So that's a key thing I want you to remember throughout this process. So let's start with the example 11y minus 9 is greater than 13. Our goal is to get y by itself, and we want it to end up on the left-hand side, which it's already there, so we don't have to worry about that. I'm going to add 9 to both sides. The only thing different here when we get our result of 11y is greater than 22 is that we've got a greater than sign instead of an equal to sign. We divide by 11 on both sides, and I get y is greater than 2. So that's my written solution. Now I want to go ahead and I'm going to put that on a number line to get my graphing solution. Remember, they want us to solve and graph. If you only do one, you're only doing half the work, only expecting that you're going to get half the credit. Here's our number line. Now when we go about graphing this, the first thing we do is we make a tick mark and we put whatever number we're interested in there. So in this problem, I've got a 2, so I'm going to put a 2 here. After that, there are two more things to consider, and I want you to go ahead and write these down if you don't remember these from your earlier math courses, about having open or closed circles and whether or not we shade to the left or to the right. First things first, let's figure out if we're going to have an open or a closed circle, and we'll do this by looking at our our inequality symbol, which is a greater than. So I've got a greater than symbol here. Because there's no equal to under it, that means it's going to be an open circle. So I'm going to make an open circle on 2. The arrow is a greater than, and you can kind of tell just by the way that it's pointing which way we're going to shade. Because I have a greater than symbol, I'm going to shade to the right. So I'm going to shade in everything to the right of that 2. Remember, a major difference between an equation and an inequality is that an equation produces exact results, while an inequality produces a series of results. My answer is anything that's larger than 2. So any number bigger than 2 will be a solution. That's why I shaded in this arrow over here, because my answers go on and on forever. I could have an answer of 5, 1,000, 193,000,000.271, anything that's greater than 2. Do keep in mind, though, that this 2 is not a solution because it's an open circle. Alright, next let's take a look at a pattern here. I've got the numbers listed here, -5, -3, 0, 2, and 10. What do you notice about those numbers? You should notice that they are in increasing order. Well, let's do something to those numbers. Let's go ahead and let's multiply all of those numbers by -1. When I multiply them all by -1, it just switches their sign. So I get +5, +3, 0, -2, and -10. What do you notice now? You should notice that the numbers are now decreasing in order from left to right. I want you to think about this when you're solving an inequality. There's a very important thing you need to understand, and that's when you multiply or divide by a negative number, you have to flip the inequality sign. Just like this happened up here, we multiplied by -1, it flipped the order. In an inequality, when you divide by a negative number or multiply by a negative number, you must flip the inequality symbol. Alright, let's solve some inequalities that involve decimals and fractions. We're going to solve and we're going to graph. In the first inequality, example 1 here, we've got 0.5 minus 0.2x is greater than or equal to 2.7. My guess is you don't like it that you have those decimals there. I want you to get in the habit of clearing fractions and decimals if you're uncomfortable with them. To do that, look at every single one of your terms and determine what is the maximum number of decimal places that you have. In example 1, all of them have only one number after the decimal. So what we're going to do is we're going to move that decimal point to the right, 1, for each term in the inequality. What we're really doing here is multiplying by 10. And just like you learned with equations, as long as you do the same thing to every term, you haven't changed the value. So now I have 5 minus 2x is greater than or equal to 27. I'm going to go through this and solve it. I'm going to subtract the 5 from both sides of the inequality. Don't drop the negative. We've got negative 2x is greater than or equal to positive 22. At this point, I'm going to divide by negative 2. Because I'm dividing by a negative, what do we have to do here? Remember, this negative here means that I'm going to have to flip the inequality symbol. So, the greater than or equal to becomes a less than or equal to negative 11. So that's my written solution. Now I'm going to go ahead and graph it. Remember, I put my tick mark, I put the number under it. It's going to go ahead and it's going to have a closed circle. The reason why it's closed is because this equal to under it. And then for shading, I look at the direction of the arrow. The arrow is pointing to the left. My solution is anything less than or equal to negative 11. So everything from negative 11 all the way to negative infinity is the solution. All right, let's look at example 2, which involves fractions. We've got negative 1/6 x minus 5/12 is less than or equal to negative 5/6. When you're doing or dealing with something with a bunch of fractions, I know that's your least favorite case. So let's eliminate those fractions. How do we do that? We do that by multiplying each term by the LCD. So the first thing you want to do is you want to look at your denominators here. We've got a 6, a 12, and a 6. The smallest number that 6, 12, and 6 all multiply to is 12. Remember, we're not looking for a GCF, we're looking for an LCD or an LCM. So the least common denominator or least common multiple, whatever you want to consider it, is 12. I'm going to multiply all of the terms by that LCD of 12. You might want to go ahead and pause and rewind during this part if you're feeling a little confused and see what we did here. So I'm going to simplify this really quickly without a calculator. 6 goes into 12 2 times. 2 times negative 1 makes negative 2x. 12 goes into 12 one time, so 1 times 5 makes my 5. Or in other words, the 12s just cancel each other. And over here, 6 goes into 12 twice. Negative 5 times 2 makes negative 10. A lot nicer than what we started with. Let's add 5 to both sides of the inequality since it's time to solve. I get negative 2x is less than or equal to negative 5. Once again, I'm dividing by a negative. I'm dividing by negative 2. So what am I going to have to do here? As a result of dividing by the negative, I'm going to flip that sign. The less than or equal to is now going to become a greater than or equal to. Negative 5 divided by negative 2 makes positive 5/2. So that's my written solution. Let's graph it. 5/2, which hopefully you know is 2.5 or 2.5. And what are we going to get here? Well, open or close circle, once again it is closed because of that equal to on the bottom. And for shading, what direction is that arrow pointing? That arrow is pointing to the right. So I'm going to shade to the right. So all numbers that are 5/2 or 2.5 or greater are solutions to this inequality. ACT or standardized test prep questions are really important to read carefully and use appropriate strategies. So this question is asking, what is the smallest number in the solution set to the inequality negative 4x minus 5 is less than or equal to negative 2x plus 9? So a couple of different ways we can go about doing this. First of all, they want us to find the smallest number. So we know we want to get the least or smallest, lowest answer in this. If you had no idea what you're doing, you should go ahead at this point and look at your solution choices and do guess and check. But that's the least effective thing to do with your time if you know what you're doing. So if you did want to do that, I would go ahead and strategize. I want the smallest number, so I would start with A. I would type or take the negative 14, substitute it in for x, and see if it's a solution. If it's a solution, great. That's the smallest number, so it would have to be your answer. If not, though, you'd have to continue down the list. So you'd see if you got to choice E, that would be really time consuming. So let's go ahead and let's do it the way that they're hoping that you're doing this, and that's by solving the inequality. So let's go ahead and solve this. We've got to get our variables on the same side, so I'm going to add the 4x over, and I get negative 5 is less than or equal to 2x plus 9. Get that variable by itself, so I'm subtracting the 2x. I get negative 14 is less than or equal to 2x. Divide both sides by 2. I don't have to flip a sign here. The reason I'm not flipping a sign is because I'm dividing by a positive 2. And I get negative 7 is less than or equal to x. Well, what's terrible about that? What's terrible about that is the fact that you have your variable on the right-hand side of the inequality. So what we're going to do is we're going to rewrite that in a form that's conducive to our problem. We're going to mirror flip it. So that means I'm going to just take everything and kind of pretend like there's an imaginary mirror and move it over. So that becomes x. Now reading this backwards, this becomes x is greater than or equal to negative 7. So that's my written solution. To answer this ACT type problem, well, my answers are anything that is greater than or equal to negative 7. So my solution would end up being B, negative 7. Compound inequalities are a little bit more complex. There are two different types, and or. And inequalities is when you're asking to satisfy two separate constraints at the same time. So you want it to be bigger than some number and less than another number at the same time. The way it's written looks a little confusing at first, but you'll see that it's written so that you've got a number less than the variable, which is less than another number. Remember, those can have equal to's under it. They don't have to both be less than. They could have one less than or one less than or equal to. So that's satisfying two different constraints. An or compound inequality is asking you to satisfy one or another constraint. So smaller than one number or bigger than another. Very important word to put in the middle there in your solution set is or. If I don't see it, we're going to have some problems. So let's go ahead and solve the inequality and graph your solution and see what this all means. Now I'm going to know if you paid attention in this video based on whether or not you're able to do a problem like example 1. It's a very easy inequality to solve and to graph if you know what's going on. First of all, our goal is always to get that variable by itself. So I want to get x by itself, which means I'm going to eliminate that 4. How do I eliminate the 4? Add it. And normally we would say we're going to add it to both sides, but really how many sides are there here? I've got a left-hand side, a middle section, and a right-hand side, so there's actually 3 portions to this. I'm going to get rid of that 4 by passing it out essentially to all parts. So I added 4 from the middle, that's gone, but I also need to do it to the left hand and the right hand side. That's the number one mistake I see people make in these problems. And it's quite easy and quite avoidable as long as you paid attention. So I get negative 4 is less than 2/3 x, which is less than 14. Lastly, I got to get rid of the 2/3. I'm going to do that by multiplying by the reciprocal, which is 3/2. If you're struggling with your fraction multiplication, something we need to review here. 3 times negative 4 makes negative 12. Divided by 2 is negative 6. The 2/3 and the 3/2 cancel. That's why we multiplied by it. 14 times 3 is 42. 42 divided by 2 makes 21. So my final solution here is negative 6 is less than x, which is less than 21. To graph it, my answer is going to be wedged in between two numbers. So instead of doing one tick mark here, I'm going to have 2. I'm going to have one at negative 6 and one at positive 21. They both happen to be open circles because neither of them has an equal to under it. In the future, one could have an equal, they both could have an equal to under it, but in this particular example, we only have the less than symbols. Now, when we're looking at this solution, I read it as negative 6 is less than x, which is less than 21, which means my answer, my x, is in between negative 6 and 21. So I'm going to shade in the middle here. The compound inequality is really saying x is less than 21 and x is greater than -6 at the same time. And that's where we get this middle portion. All right, let's try an OR problem out. We're going to solve two separate inequalities and then put them together on the graph. So first part, x plus 2 is less than or equal to 5 is quite easy. Subtract the 2, and I get x is less than or equal to 3. No big deal there. Or 2 times x minus 1, so I'm going to do the distributive property. I get 2x minus 2 is greater than or equal to 6. Add the 2 to both sides. So 2x is greater than or equal to 8. Divide both sides by 2. And I get x is greater than or equal to 4. So my answer here is x is less than or equal to 3, or x is greater than or equal to 4. Just like with the and, I've got two separate tick marks. I've got a tick mark for 3 and a tick mark for 4, but here's the difference. We're going to go ahead and we are going to graph this first part, and then we'll look at the second one. X is less than or equal to 3. Well, that's going to be a closed circle on 3. Less than or equal to, pointing to the left, I'm going to shade to the left. So as of right now, that's my solution set. So anything that's 3 or smaller would be a solution. But we're going to add the OR part now. Or x is greater than or equal to 4. Once again, that's a closed circle because of that equal to. In this case, it's greater than or equal to, so I shade to the right. So my answer is anywhere that it's green or purple. So really, there's only one part that's not a solution, and that's anything that's bigger than 3 or less than 4. Everything else from -infinity to infinity is a solution. I'm going to put up a problem. I want you to try it out. I'll put up the solution, and if you have a question, make sure you ask about it in class tomorrow. You try -13 less than or equal to -3x minus 1 less than or equal to 14. Hit the pause key now. Alright, here's your solution. Places you might have gotten mixed up were when you divided by the negative number, and the fact that we had to reverse our solution so that it was in order from least to greatest, which means that we had to do that mirror flip. Once again, if you have questions, bring them to class tomorrow. Alright, to wrap it up, remember we're solving inequalities the same way as we solve equations, but you need to remember to flip that inequality symbol whenever you multiply or divide by a negative. And inequalities meet both requirements, and so they're the wedged case where you get a solution in the middle, while OR inequalities need to just meet one requirement, and that's often when you have the two shaded areas heading in opposite directions.